Hey, this is Mrs. Harris, and we're going to continue our study of section 5.3. And now we're going to be talking about the quotient property of radical numbers. Quotient in math terms means that we are dividing. And we have a division line right here, and we have a division line right here inside of the radical. So the quotient property of radical numbers says that the square root of some number a divided by some number b equals the square root of a divided by the square root of b. And there's a couple of things that we have to know about this. First, because b is on the bottom, we have to say that b has to be greater than 0. And then we also know that a has to be greater than 0. So for our quotient property, we have the square root of a divided by b is equal to the square root of a divided by the square root of b, so long as b is greater than 0 and a is greater than 0. This looks very familiar to the work that we did on the multiplicative property. So let's see how this works. And we're still working on simplifying. And when we're working on simplifying, we are not looking for both the positive and negative root. We are not solving. It just asks us to simplify. So how to simplify quotient radical expressions. Here's number 38 from your textbook page number 267. So it says the square root of 100 divided by the square root of 81. So how do we write that? Well, I can take a divided by b and break it up into two separate square roots. So let's go ahead and do that. So I have the square root of 100 divided by the square root of 81. Well, the square root of 100 is 10, and the square root of 81 is 9. So here is the simplified form of the expression, the radical expression, the square root of 100 divided by 81. Well, that doesn't seem too difficult, does it? But let's look at another example. And this will just be a regular example. It is not one of your homework problems. So let's go ahead and take a look at, let's see, the square root of 5. Let's see, square root of 5 divided by 2. Well, this here is going to bring up a little bit of a problem, but let's take a look at it. So we can use the quotient property to say, well, it's the square root of 5 divided by the square root of 2. And when we did multiplication, we said that a expression was simplified when there was a prime number or prime factors underneath the radical sign. So you would say, hey, Miss Harris, we are done because 5 is prime and 2 is prime. Finished. This is my simplified answer. Unfortunately, it's not, because we have something called rationalizing the denominator. What it means by rationalizing the denominator, it says you can never, ever, ever have a square root in your denominator. The denominator is downstairs, and that means it is this right here. So down here, you can never, ever, ever have a square root, ever. Well, that's a problem. Well, how are we going to get rid of this square root? That's where we come up with rationalizing the denominator. So let's continue and work on this example. So we are still with the same example that said the square root of 5 divided by 2, and we use the quotient property to say, well, it's the square root of 5 divided by the square root of 2. But we know we can never, ever, ever have a square root of 2 in the bottom. So the way that we rationalize the denominator is whatever is in the bottom here, we multiply the top and the bottom by that square root. So I'm going to multiply the top and the bottom by the square root of 2. This is called rationalizing the denominator. Now the square root of 2 divided by the square root of 2 is equal to 1. So since this equals 1 and we're multiplying something by 1, The multiplicative identity tells me, hey, I don't change what this value is. So this is a legal math move. So now what this looks like is it says the square root of 5 times the square root of 2 divided by square root of 2 times the square root of 2. And now what we use are the properties we learned about multiplication. So again, the multiplicative identity said that the square root of a times b is equal to the square root of a times the square root of b. As long as a is bigger than 0, then b is bigger than 0. So I'm going to kind of combine these together, okay, because they're separate and I know I can combine them from the multiplicative property of rationals. So this becomes the square root of 5 times 2 over the square root of 2 times 2. Well, this is a prime factor. 5 is prime and 2 is prime. So it's just going to stay as 5 times 2 is the square root of 10. Now 2 times 2 is 4. And I know that the square root of 4 is 2. So am I done simplifying? Yes, I am. So this is how you use the quotient property of radical numbers to simplify expressions. And we looked at an example that was a little bit easier, but in this example we had to do something called rationalizing the denominator.